Guys, welcome back to my channel. I wasn't able to make any video because I was busy with my competition at WRO, but this video is all about tips and tricks for building a better FLL and WRO robot using SpikePrime or VV3. Let's get started. Before we start off, I want to clear one thing, that this is the robot that I'll be using for explaining all my concepts. Now this is a robot that I've built. It's a base robot using the SpikePrime core set. Now, without further ado, let's get started with the tip number 1. This tip applies more towards WRO rather than FLL, because in WRO you have to build your robot on the competition day on the spot. Now, the thing is, a lot of teams build really complex robots and lose points because they're unable to complete the robot and they're unable to run. So, for example, this robot, it uses very simple and not too complex building techniques. The most major building technique that I've used that's complex has got to be the front part, that is supporting these casters, the pulley wheels. Now from this, the tip number 2 comes as well. Try not to use one of these caster wheels. The thing about these caster wheels is you might be using one of these at the front in the middle of your robot. So for example, this is my robot. I might be attaching one of them right here. Now it seems fine in first place, but there are a few issues with it. First issue, that this ball gets a lot of dirt and dust stuck onto it. Now that dirt and dust is quite hard to remove because you can't really access it. Like in the EV3 kit, you could actually remove the ball and then clean it and put it back. But again, in the holder part, the socket area, dust accumulates and it's a problem. Now the second problem has got to be, if you're attaching this, as I told you, you'll be attaching it around the middle area. Now for example, your robot has some more attachment that adds weight towards this side. Then your robot has only one caster that's supporting it in the middle area, so no support here would cause the robot to bend a bit here and cause this wheel to lose traction. Now this losing traction causes a lot of turning problems. I can say from my own experience as well. Now from this, along with this comes the third point, that is use pulley wheels. Now instead of using these, try using pulley wheels as I have used here. Now these pulley wheels are quite useful. They are simple to build as well. Rather than inculcating this huge piece of junk, you can attach this sleek looking wheel. Now in some cases this might be better as well, but it depends from person to person. Honestly, I recommend using these. So I've attached this to a 2x4 L-shaped beam, and then I've easily attached it using one of these frictionless connectors, the pegs. Now along with this comes the next point, that is symmetry. Your robot should have symmetry. Now I can say again from experience that symmetry has caused a lot of problem in my coding. I'm a main programmer, so I never really realized a lot of my hardware part till now, since I've started doing a bit of hardware as well. So the thing is that when I was programming my robot for junior high this year as well, the thing I was seeing that my robot wasn't turning accurately. For example, I was taking a 90-degree turn even using a gyro. The 90-degree wasn't that effective. Every time it would come around like 88, 89, and or it would overshoot, it would undershoot. So it was a problem. Now to deal with it, I asked my coach and he was like, check the symmetry. Now the symmetry is one of the major problems. If your robot isn't symmetrical from the center, there is going to be a weight imbalance. Now this weight imbalance is going to cause a robot not to turn accurately. Now for example, here the only imbalance has got to be the color sensor. But it's quite light, so I don't think so it makes a huge change. Even after rigorous testing, I did not really find any defect with this. Now, so try to build your robot as symmetrical as possible. Along with this comes the next point, that has to be build a frame. As this robot has a frame, as you can see, the frame has a lot of advantages. First of all, aesthetics. Sounds like a nitpick, but yes, aesthetics help. For example, you're in FLL, you have to show your innovation project. Now the judges are actually going to judge you on the basis of how your robot looks as well. Any open pegs and all, minus points. But if they see a frame, they usually like to see a frame because it adds a bit of density into your robot. Not only that, it has one more advantage. The back part helps in wall aligning. In any competition, in your table you have walls, so you can go back and align to the wall and maybe do some wall thingy, I don't know, do something. Now next point, for this only, another thing for frame has got to be your wheel movement. Now when there is a frame, the wheel movement is constricted. I could have attached one more wheel, but I thought why to add extra weight. So instead I added was a few biscuits. 2 biscuits are there on each side, and there is a bush. Now this helps the robot's wheel not to move side to side. The robot will only move front and straight. This is quite useful. Again, in turning purposes or even while line following, another problem might come. While turning, this might have a bit more traction and the wheel might shift over there if the frame isn't there. Now that will cause again discontinuity in the robot's movement, and for your other runs the problem is going to be increased every single time. Now from this there has to come my next point, that is try to attach is an external motor. Now this is more towards FLL, because in FLL you do not expect one robot to complete all missions. Since there are a lot of missions, you have to build different attachments for your base robot, and you attach it and remove it. So for example, here there is an external motor which has an O-frame connected to it. Now I can attach this O-frame, another O-frame which uses these cross axle pegs, and I can simply attach them. Now I can attach and remove them using one hand, and this saves a lot of time instead of using those blue pegs or black pegs. And also it won't fall until someone does this, which is really rare or almost impossible considering the fact that FLL won't allow you to do. I think so, never tried it. Now from this comes my next point, which is my final point, that is never let your motors lose traction. Now for that there are a few things. Again, symmetry, disbalance of weight shouldn't be there, and one more really important point that I like to cover. Now this is a thing that a lot of teams do and even I like to do, that is placing the Spike Prime hub or Robot Inventor hub or the EV3 brake or the NXT brake if you're using it for some reason upon the wheels. Now the thing is that if you're attaching it upon the wheels, one major advantage you have other than attaching it in the front or somewhere else. Now if it's in the front, then your robot is going to have more weight towards the front. So first things, the robot will lose traction, and if the robot moves forward, it will have this really weird jerk. Now the second advantage that you're going to have, that is going to be, for example, you're picking up something. So for picking up, those game elements are going to add weight towards the front part. So those to even out the balance between the back and the front, the EV3 brake on the wheels is going to help adding traction on the wheels, so your robots won't lose any traction. Now this was the conclusion, and I'd like to end this video by saying please consider subscribing, and I'd like to add the studio file to it. I'll try to add it, and I was unable to make any videos since I was busy with WRO this year, and FLL isn't happening here in India, otherwise I would still be busy. Alright, see you next time. I'll try to do regular uploads from now on back. So see you next time. Please consider subscribing.